Okay, here we have the Unit 2 review. So keep in mind your test is coming up. So I'm just going to go through the evens on here. Most of the review, for the most part, I think through pages like 1 through 5, it's a mirror, meaning like question 1 and 2 are the same type, question 3 and 4, etc. So I'm going to go through the evens, and then I think towards the end they're not as mirrored, so I'll probably go through a lot of them once we get to that page. So it says write an equation for the linear function f satisfying the given conditions, then graph y equals f of x. Okay, not really a lot of room to graph it here, but I can do a quick sketch. Okay, so keep in mind here, when you're given this function notation, this is actually giving you two different points. So this is giving you an x1 and a y1, an x2 and a y2. And in order to be able to graph it, really I need to be able to write it in that y equals mx plus b form, meaning I need a slope. So the first thing I'm going to do when given 2 points is calculate the slope. So if I say x1, y1, and x2, y2, then I know my slope formula, m, is y2 minus y1 over x2 minus x1. So that's minus a negative, so that turns to a plus. And so this tells me that my slope, I get negative 8 over 4. And that gives me a slope of negative 2. So I didn't answer the full question yet. That's just telling me what the slope is. So now I need to use my point slope formula and plug that in. So recall your point slope formula is y minus y1 equals m parentheses x minus x1. So it's y minus y1, so minus 6, equals m, that's the slope that we just found, parentheses x minus x1, and again that's minus a negative, so it'll turn to a plus. So since I want to be able to graph it, I'm probably going to rewrite this in y equals mx plus b form. So negative 2 times x, so that gives me negative 2x. This would give me a negative 6, and then I'm going to add 6 to both sides. So it gives me negative 6 plus 6, which is 0. So the equation of the line is just y equals negative 2x. It did say to graph it, so let me see if I have another color over here. So if I was to graph this on a set of axes, just a quick sketch, it would have a y-intercept of 0. If you need to write that plus 0 there to help you, you can. Okay, so it has a y-intercept of 0. I also know these 2 points are on the graph, so you could always plot negative 3, 6, and 1, negative 2. Okay, or you could have just, once you know this, the equation is down to right 1, and then you could have graphed it from there. So your graph is going to look something like this. Okay, so there's your graph. That is just a line with a negative slope of 2. Okay, next it says describe how to transform the graph f of x equals x squared into the graph of the given function. So it's just asking me for that list of transformations. So here, remember the inside, this tells me that you're going to the left 3 units. So I'll say left 3. This plus 1, that tells me that we're going up 1 unit. And then the negative, okay, that negative tells me that there's a reflection over the x-axis, and then the 1/2, sorry, I'll just write it here, so that 1/2, that implies that there is a vertical compression or a shrink. Okay, so this is going to look like that square root curve, so it's still going to have that parabolic U shape, but it's going to be flipped upside down. It's going to be a little fatter than usual, a little wider. It's going to be shifted to the left and up. All right, moving on to number 6. Find the vertex and axis of symmetry of the graph of the following functions, then graph it. Okay, So to find your axis of symmetry, remember your axis of symmetry is x equals negative b over 2a. So in this equation, negative b, well, that's the opposite of negative 6, so it's a positive 6 divided by 2 times 3, so that just gives me a 1. So my axis of symmetry is the line x equals 1. So you could put that in there, so that's going to be x equals 1. It's going to be this vertical line right here, okay? And then if I wanted to find the vertex, you take that axis of symmetry and plug it in. So you could say, what is f of 1? So if you plug in x equals 1 there, 1 squared is 1 times 3 gives me 3 minus 6 plus 2. So that's negative 3 plus 2 is a negative 1. So that means my vertex is the point 1, negative 1. Now the other option you have here, if you didn't want to find your vertex that way, is you could complete the square in order to find that vertex. Okay, you could also complete the square, so there's two options there. And so if I'm graphing this, I'm going to go to 1, negative 1, there's the point, 1, negative 1, there's my vertex. This parabola is opening upwards, so you could open it upwards like that. There we go, that seems to be focused a little better. So I know it's going to be opening upwards, so what I would probably do next is try to find the y-intercept by plugging in x equals 0. That'll give me another point on the graph. So if I plug in 0, I get 2. So there's a point at 0, 2, right? That's your y-intercept. So at 0, 2, and I know these graphs are small, and I know it's symmetric, so I can just go on the other end, or on the other side of that axis of symmetry. So this is a pretty narrow parabola, but you get the idea there. Alright, next thing we're going to talk about this power function here. So what I would recommend for this is to plug in. The other thing to answer these two questions, so the power is in the constant of variation. Remember, the power square root is the same thing as 1/2 power. So this is mathematically equivalent to y equals 4x to the 1/2 power. So the power is 1/2. The constant of variation is 4. And in order to graph this, I would probably make a table. When I make a table, I always try to plug in a negative number. Here, when I try to plug in, say, a number like negative 1, I can't take the square root of a negative, so there's a non-real answer. And that makes sense because it is a square root graph. So if you just kind of make a table, I'm going to plug in some numbers that are nice to plug in. So I'm going to plug in 0 because the square root of 0 is 0. Times 4 is still 0. When I plug in a 1, I get the square root of 1 as 1 times 4 is 4. I'm not going to plug in a 2 because the square root of 2 is not nice. I'm not going to plug in a 3, and then I'll plug in a 4. Square root of 4 is 2. 2 times that 4 gives me an 8. This will give me some points to plot. So I'm going to have a point at 0, 0. At 1, it's all the way up to 4. And at 4, it's all the way up to 8. So this square root curve is growing really rapidly because it has that vertical stretch going on. Okay? Alright, so let's go on to page 2. Alright, so on page 2, you are given a vertex and the point, and it's asking you to write the equation for the quadratic. What you need to know about that is the formula.
Mama?
The y equals a x minus h quantity squared plus k. Notice here you're given the vertex. Your vertex is h comma k. Your x point, or your point is x1, y1. So once you have your hk and an x and a y, you're literally just dropping those into this formula and solving for a. Once you solve for a, then your goal is to rewrite this formula again, but you're going to leave the x and the y as variables. So it's kind of a two-step problem. So first, we solve for a. So I plug in the y value, the x value. Remember, you have to do the opposite of the h. Don't forget to square it. And then plus k. Alright, so now it's just some orders of operation here. So you get 4 squared is 16. The biggest mistake people make in this problem is they accidentally add these two numbers together and they say 17a. That's not what you need to do. Remember your orders of operation. Here we square it. 4 squared is 16. That 16 is attached to this a by multiplication. So you need to subtract this 1 from both. So subtract 1 from both sides. So you get -3 equals 16a, then divide. So you get a equals -3 over 16. It's not the most beautiful coefficient I've ever seen, but it doesn't really matter because all I'm going to do is just plug that back in. So now you take this, okay, you take this a value and you plug it right back in up here for a. So you just have y equals, the a was -3 over 16, parentheses x, you would still use the h and the k, so it's +1 quantity squared, and then your k value was a +1, so +1 on the outside there is your final answer. Okay, moving on to your average rate of change problems. So even though this is an odd, I'm still going to do it because it has a couple. So find the average rate of change of h versus g. Well, here the average rate of change is going to be constant for a and b because that's just a line. The average rate of change, aka the slope, is constant on a line. So your answer for a and b should be 7. I'll do part C because that's a little more interesting. This is a parabola, so the average rate of change is changing. The slope of the parabola is changing as you kind of go there. So your average rate of change formula, remember your average rate of change formula, so average rate of change is going to be f of b minus f of a all over b minus a. So in this problem, the a value is 1 and the b value is 4. So you're going to need to figure out what is f of 4, plug it in right here, then figure out what's f of 1, plug it in there, and then all over 4 minus 1. So the denominator is usually the easy part, so that'll be 4 minus 1. And then you might need to do a little scratch work off to the side here to figure out what's f of 4. Well, f of 4 means I need to plug 4 into this equation here. So that'll be 3 times 4 squared is 16 plus 2. So 3 times 16, right? You get 48 plus 2 is 50. And then I also need to figure out what f of 1 is. So f of 1, you take 1, plug it in. 1 squared is 1 times 3. So you get 3 plus 2 is 5. Now I take those and plug them in over here. So you've got 50 minus 5 all over 4 minus 1. So we've got 45 in my numerator over 3, and that actually divides nicely, and I get 15 as my answer. That's my average rate of change. Over here I had to do a little scratch work, but that's how you find that. Okay, describe the end behavior of each polynomial. So I'm going to select these. Remember, I'm going to take one that has an even degree. Be careful, this was a trick over here. Here, that 3 is the degree. It was written out of order. So what you want to do when you are finding the end behavior, there's 2 things you need to look for. You need to look at the degree and the leading coefficient. So I'll just say LC. So you care if the degree is even or odd, and you care if the leading coefficient is positive or negative. Okay, those are the things you're looking at when you're doing the end behavior. So on number 12, it's in the degree 4. So here it's a degree 4, okay, and the leading coefficient is 2. 4 is an even, and 2 is positive. So if you have a polynomial that has an even degree, that tells you it has the same end behavior on each end. And this is positive, so that means both ends are going up. You could write this as x goes to negative infinity. That means the left-hand side. You could say y goes to infinity. You could say as x goes to infinity, that's the right-hand side, y goes to infinity. Or you could say rise on the left, comma, rise on the right. Okay, so make sure you're familiar with both those notations. You'll need to know them both for the test. Sorry, let me scooch that up for you. And then let's do one that has an odd. So I might as well do this one because I already talked about it. So here, your degree is 3, and the leading coefficient is a -1. So again, that 3 is an odd number, -1 is a negative number. So you care about the even oddness of the degree and the positivity of the leading coefficient. So because it is an odd, that means it does different things on each side. So one end is falling, one end is rising. And because it has that negative first, kind of go back to one that you know that this is y equals -x. So this one is going to be rising on the left. So you could say rise on left and falling on the right. The way to do that with the infinity notation, you could say as x goes to -infinity, y goes to infinity. As x goes to infinity, y goes to -infinity. Okay? All right, and then you can move to page 3. Okay, I'm actually probably going to do 16 and 17 because these are really important. So let's take a look. It says basically we're trying to graph this polynomial. Remember, this is a non-calculator test, so we're trying to do this without our calculator. So first thing I want to do is notice the degree and the leading coefficient. So just like the last question, that's actually part C, the end behavior. I'm going to do that first. So because it's a 3 as the degree, I know it's doing different things on either end. And because it's positive, I'm kind of thinking of y equals x, right? So it's falling on the left, falls on the left, and it rises on the right-hand side, okay? So I know that's what's going to be happening there. And then determine the maximum number of turns. Remember, your number of turns is the degree minus 1. So 3 minus 1 is 2. So I'm expecting this to have 2 bends or turns. It's going to be falling on the left and rising on the right. And now I'm going to go ahead and find the zeros. And this got a little messed up for the copying. I think these are supposed to be, oh, I guess this can go over here. So falls on the left, rise on the right, and then determine the maximum number 2. So turns is going to be 2 at the most, and then I'm going to graph it there. So determine its zeros. Here I'm going to take out a GCF. So if I pull out a 5x, I'm left with x squared minus x minus 2. And then I can factor this further. So I'm going to have still y equals here. And if I'm finding the zeros, I'm going to say 0 equals 5x. And then to factor this, I need to multiply to a -2. So one's going to be positive and one's going to be negative. One factor will be positive, one will be negative. And then I want to have a -1, so it'll be -2 plus 1. If I FOILed that out, I'd get a -2 plus 1 would give me this -1. And positive 1 times -2 is -2. So these are my factors, and that gives me roots that are 0, -1, and 2. So my roots are going to be x equals 0, -1, positive 2. Okay? So once I have those, notice that I got each one of those factors exactly one time. 1 is an odd number. So I just put a little C underneath all of them, reminding myself that they cross. So determine the zeros and the multiplicities. So my zeros were 0, -1, 2, and I'm going to say they all cross. Okay. Oh, I guess I could have put that on that line. Doesn't really matter. Okay. So when I go to graph this, I go to -1, positive 2, and at 0, I put my zeros. Okay. Then I go to my end behavior. It's supposed to be falling on the left. So a little to the left of this, I put an arrow down. And then it's supposed to be rising on the right. So a little to the right, I put an arrow pointing up. And now, since I cross at all of them, it's just a little game of connect the dots. So cross, cross, cross. And so now I connect the dots, and I hope that I only have to turn twice. Okay? So I cross, cross, cross. Notice that I have 2 bends in my curve. Okay, so there's my sketch there. Now notice, I don't know how high this peak is or how low this valley is. It's just a sketch. So we'll go ahead and try the next one. So on this next one, the degree is 4, and the leading coefficient is positive, so determine the end behavior. Since it's an even degree, it's going to do the same thing on both sides. So because that 9 is positive, it's going to rise on the left and rise on the right. Okay. The number of turns is going to be at 3 at the most, 3 at most, because I do the degree minus 1. And now determine the zeros of it. So I'm going to take out a GCF of just an x this time. I'm sorry, x squared. So if I pull out an x squared, I'm finding the zeros. So if I pull out an x squared, I'm left with 9x squared minus 3x minus 2. Okay. And now you may need to do some AC factoring there. Okay, if you need to do AC factoring, you can kind of do that off to the side. So your A times C, so if you need to do that, A times C gives you negative 18, right? And I would probably, you're trying to multiply to a negative 18, but also add up to negative 3. So you do something like 9x squared minus 6x plus 3x minus 2. Your GCF of each of those, your GCF there is a 3x. You get 3x minus 2. Your GCF there is a 1, so plus 1. 3x minus 2. Hopefully you don't need to continue to keep going there, and you can kind of see your factors right away. So here I have an x squared, a 3x plus 1, and a 3x minus 2. Just make sure that boils. 9x squared, that gives me negative 6, plus 3 is negative 3, and a minus 2. Perfect. Oh, or minus 2, perfect. All right. So now that I have those factors, I need to determine the roots. Well, notice that this x is squared. That's different than the one above, because now when I set this equal to 0, I get x squared equals 0. That means I need to take the square root of both sides, so I get positive and negative 0. So this time I get that my zeros are x equals 0, but that one's repeated. This one would give me negative 1/3 and then positive 2/3. Because I got that 0 repeated, because it was squared, that one's going to touch, and these other two are going to cross. So when I go to sketch this, okay, I don't know, I'll put, say this is negative 1 and this is positive 1. I'm going to have my zeros might be at negative 1/3, so right there, 0, and at 2/3, so something like that, give or take. Remember, it's just a sketch. From there, I need to say that it's going to rise on both sides. So a little to the left, I go up, then a little to the right, I'm pointing up. And then it's just a game of connect the dots. I need to cross here, touch 0, and cross there. So I'm coming down, I have to cross here, I need to come back up and touch, and then I need to go back up and cross. So that's what I end up with. Notice this one does have 3 turns in it, so I'm still within there. Okay? I don't know how low either of those values go. Maybe they're the same, maybe this one goes way down. Those are just things I'm not sure of right now. Also, on both these examples, it's important to note that the y-intercept was 0, 0 because I was able to factor out an x. Remember, there's going to be those ones coming up that are a little bit more challenging because you can't just take out a GCF. All right, and let's go to page 4. All right, there's 2 different types of examples here. So I'll do 19 and 21. The first one is an example of long division. The second one, I can use synthetic division. So whenever we're using long division, I can't use synthetic because it's not of that form x plus or minus some constant. It has that 3 there. So I'm going to take that and write it out front. So I've got 3x plus 1. And then I always make sure that I don't need any 0 placeholders. So here, 3x to the 4th is fine, and then I have minus as my cubic term comes next, so that's fine. Next comes the squared term, then my linear term. Oops, I'm going to have to make this a little longer, and then a minus 6. Okay. So once I have that in there, I might actually try to use a couple different colors here. So when I'm going to do this, the 3x that's here is kind of what's in control of the problem. So you need to kind of say, all right, when I go to write this, I need to turn this 3x, I need to figure out, like, what do I need to multiply this by to make it into this first one? So I'm looking at just these first two. So to multiply 3x by something to turn it into a 3x to the 4th, I need to multiply it by an x to the 3rd. So I write it above. See how this is the x to the 3rd? I'm actually going to write it above there. It'll help line things up for me. So I say x to the 3rd. Now I multiply x to the 3rd by this entire binomial. So when I multiply that, you get 3x to the 4th, and then plus x to the 3rd. Okay, so plus x to the 3rd. And now this is where I told you we're going to draw a line and change the signs, meaning all the positives go to negatives, the negatives go to positives. So once I do that, this zeroes out, and then when I put these together, I'm going to get a negative 6x cubed. Okay? Now I can bring down the next term. Okay, so then I go back. This guy is in charge, and now this negative 6x cubed is in charge. What do I need to multiply this 3x by to make it a negative 6x cubed? Well, I need to multiply it by a negative 2x squared. So then I write up here, negative 2x squared. Now I distribute a negative 2x squared across this binomial. So you get negative 6x cubed, and then minus 2x squared. Okay, so you draw a line, then change the signs. So now those are both positive. When you add them up, those zero out. You add these up, that also zeroes out. I'm still going to write it as a 0x squared though, okay? Because otherwise I think when I go to bring this down, I might get confused. So now I can bring down this plus 3x. All right. What are you going to multiply this by to make it a 0x squared? Well, the answer is 0. So you say plus 0x, multiply this times there, 0 times this, so you have 0x squared, and then plus 0 x's, draw a line, change the sign. Now here changing the sign doesn't really matter because they're zeros. But it kind of helps you keep those terms organized. These go away, and then I still have a 3x here. All right, who's in charge? This 3x. What do you need to multiply 3x by to make it a 3x? Well, just a 1. So then you put a plus 1 up here, and then you multiply it by that. So you get 3x plus 1. And then you draw a line, change the signs. Those go away, and you end up with a negative 1. And then the very last time, you still have one more thing to bring down. I know it's a long drop. Okay. I drew that line too long. I should have dropped this down right there. Okay. So, oh shoot. All right. I'll put that negative 6 goes there. Okay. So, when I do this, then this should be a negative 6 minus 1 gives you a negative 7. Sorry about that. I didn't drop down this negative 6 before I put that 1 there. So 1 times this gives you 3x minus 1, and when you add that to the 3x minus 6, you end up with a negative 7 as the remainder. So your final answer would be this top thing, and then also minus 7 over the original. Okay, so your answer would be x cubed minus 2x squared plus, you could just say plus 1, and then minus 7 over 3x plus 1 as your answer. Okay, so there's the long division. And now we'll move on to synthetic division, which is a little bit more goofy of a setup, but I think it's a little bit easier. Okay, so just kind of scooch this up. So when you go to do this, remember, what goes in the box is the opposite of this. Basically, you set this equal to 0. This is the factor, and you want the root. So you're going to say, all right, -2 goes in the box. And then you copy down the coefficients, again, keeping an eye on if you need to put a 0 placeholder here. Because I have a 4, 3, 2, linear, and a constant, I don't need a 0 placeholder, but I'm telling you right now there's one on the test where you will. So we write those coefficients down. I always leave myself a little bit of room. I draw a line, and this time you start by bringing down the 1. Okay? So it's like reverse. So we multiply the diagonal. So you multiply these two and get a -2, and you add the vertical. So again, you multiply the diagonal, add the vertical. That gives you a 1. Multiply the diagonal, add the vertical. Multiply, add. Multiply, add. So here, how do I take that and then turn it into an answer? Well, since I was taking a quartic and dividing it by a linear, it's going to go down a degree. So this was an x to the 4th. Now my answer is going to be x to the 3rd because it was a coefficient of 1. So 1x to the 3rd plus 1x squared minus 1x minus 1. And my 5 is the remainder, so it's plus 5 over the original divisor there. So there's my final answer on that one. Okay. Now the bottom here is asking us to determine if one is a factor of the other. Okay. So determine if x plus 1 is a factor of this, meaning does it divide evenly. So what we're going to do here is kind of the same idea. You take this, set it equal to 0, and that's a 1. So we want to figure out what f of 1 is. If I get a 0, that means that it's a factor. If I get a number that's not 0, then it's not a factor. So when I plug in 1 there, I get 2 times 1 cubed is 1, plus 1 squared is still 1, minus 5 times 1 is minus 5, plus 2. So I have 2 plus 1 is 3, minus 5 is -2, plus 2 is 2. So this equals 0. So that tells me that x minus 1 is a factor. Okay, if I would have gotten a number like 4 or -3, then it would not be a factor, but that is a factor. We can go ahead and go to the next page. Okay, for number 25 over here, 24 and 25, they're just asking us to write the list. They're only asking us to write the list here, so it doesn't say anything about testing them. We'll do that on the next one. So here, to write the list, what you want to do is you have to look at two things. You have to look at the constant at the end, and you have to look at the coefficient in the front. So the first thing you do is we say it's plus and minus all the factors of 8. So 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. Then you have to take those and divide them by the factors of the first number. Well, lucky for us, the coefficient there is just 1, so I don't have any additional ones. Okay? So that means my list, so this list has a total of 8 numbers. 8 numbers in it. Because you have 1, 2, 4, 8. Here, I'll write them out. 1, 2, 4, 8. But then it also has all the negatives. So -1, -2, -4, -8. Okay? So make sure that you can answer a question like, what's the sum of all the roots? Or what's the product of all the roots? The sum is easy because obviously they'll just cancel each other out and you get 0. But I could ask you for the product of the roots. Okay? So just be prepared for a question like that. And then we've got something like 27 here, write the list of the zeros, determine basically what's going on, whether they touch or cross. So basically everything but graphing it. Okay, so let's do 27 here because it has a coefficient, so it'll kind of help us with that list. So first of all, my list of potential zeros, I need the factors of 6. So 1, 2, 3, and 6. And then I need to take that list and divide it by the factors of 3. Well, 1 doesn't change any of them, but 3, okay, 1 and 3 are the factors of 3. So now I need to divide each one of these by 3. So 1/3, 2/3. Here's the deal though, when I divide 3 by 3, I get a 1, that's already on the list. When I divide 6 by 3, I get a 2, which is already on the list. So here's my list of potential roots. Notice that this list is going to have 12 things in it because I've got 6 positives and 6 negatives. And now I need to test to figure it out. I cannot just take out a GCF on this one because notice there's no x with the 6. So it's not like those easier ones I had to grab here. I'm going to have to do my rational root test and pick a number and try it. So my suggestion on your test is that you pick 1 or -1 first. So let's see what happens when I pick 1. So I pick the number 1 and I do synthetic division. Remember, when you do synthetic division, it's with these numbers up here. So it's a 3, 2, -19, and 6. I leave a little room. I start by bringing down the 3. So when you bring down this 3, remember, we multiply the diagonal, add the vertical. Multiply the diagonal, add the vertical. Okay, this one doesn't look like it's going to work. So this, okay, when I add 6 to that, I get a -8. Because this -8 is not a 0, that's when I kind of put a little sad face. That means that 1 was not the root, okay? So that means I need to try something else. So maybe you try -1 or you try -2. I'm going to try +2 this time. I already tried 1, so I'm going to try 2 now. So I do the same thing. I write a new problem. Okay, start by bringing down the 3. 2 times 3 is 6. 2 plus 6 is 8. You multiply the diagonal, add the vertical. Multiply the diagonal, add the vertical. And when I get a 0, that makes me happy because that means I'm done. So this one, this first example, I don't want to like cross it out, but it really didn't give me any information. It was kind of a waste of time. But I didn't know that. So I want to turn these into my factors. Remember, if the 2 was in the box, that means that the factor was x minus 2. Now I need to figure out this was an x squared, I'm sorry, it was a 3x squared plus 8x minus 3 was the quadratic. Okay, those are my factors. So then you need to factor this again in order to be able to get the roots. So I'm still just going to keep this x minus 2. This one I don't think I need to do AC factoring because 3 is a prime number, so I know it's got to be a 3x and an x. Also, this 3, I know it's got to be a 1 and a 3. I just have to watch my positivity to make sure I get the right thing. So I think the minus 1 has to go here, and the 3 goes there, a positive 3. Let me just double check. So 3x squared, that gives me a plus 9 minus 1 gives me a positive 8 minus 3. If you need to do AC factoring on that, that's fine. You just have to do it off to the side. So these are my factors. So that means that my roots are x equals, well, 2, 1/3, and -3. Since each one of those roots was individual, I didn't have any repeated roots, that would mean that they all cross. Okay, they all cross the x-axis there. None of them are bouncers. Okay, and state whether the root touch or cross. I did that. Determine the zeros. Okay, so we've got that. So that's how you do something like 27. I'm going to go ahead and do one like 28 because it has a little hidden 0 you need to put down. So very similarly, when I do this, I'm going to come up with my list of potential zeros. So this time I use my factors of 6. So it's going to be plus and minus 1, 2, 3, 6. and then divided by the factors of 1, so I don't get any additional, so those are the numbers that I can test, positive 1, 2, 3, or 6, or negative 1, 2, 3, or 6. My suggestion on your test is that you always started with either 1 or negative 1. I'll just try 1 this time. Now be careful on your synthetic division here. Notice how you're missing the squared term, so you need to put a 0 down in place of that squared term. Oops, I didn't need an X there. Okay, so I start by bringing down the 1. Remember, you multiply the diagonal, add the vertical. Multiply, add, multiply, add. And again, I got 0 there on my first try. What luck. So this tells me that my factors were x. Remember, I do the opposite of what's in that box, so x minus 1. And then I have to turn this into the quadratic. So it's x squared plus 1x minus 6. And then I need to factor that again. So I just recopy the first factor. And then I need to multiply to a negative, so I know it's going to be a plus and a minus. I need to multiply to a negative 6 and add up to a 1, so it'll be a positive 3 and a negative 2. So this tells me that my roots are going to be 1, or x equals 1, negative 3, and 2. Notice how each one was an individual factor, and I didn't get any that repeated, so they all cross. Okay, if I would have had one that repeated, it would have bounced. All right, so that gives you a couple examples of those, and moving on to the last page. Okay, these next two, we're working backwards. So it says, write a polynomial that would have a leading coefficient of 2, and this one says a degree 2 with negative 3 as the only real 0. And we are going to let you leave these in factored form on the test. So something like this, you would just do a 2, has to have a leading coefficient 2. And then if negative 3 is the 0, then it would have been an x plus 3 would have been the factor. And so part of you might think that's good, but remember, it has to be a degree 2, so you would have needed 2 of those. So, you could either write it as that squared, or you could write 2 of them. Now this, if you did FOIL that out, it would have a leading coefficient of 2 and be degree 2, because you would multiply those out. So something, the next one, you would say a degree 4, and if the zeros were there, so we'd still need a 2 up front, because that'd be the leading coefficient, but then, okay, each of these have a multiplicity of 2, so that means that you had them each twice. And then it has to be the opposite of that, so that's going to be an x plus 2 and an x minus 4. And again, you could, just leave it in factored form, okay? All right, going on to number 32, determine the x-intercepts and the y-intercept of the following. So just make sure that you know how to identify each of those. So for something like this, if you need the AC factor to find the roots, that's fine. Your y-intercept, so the y-intercept's the easy one. Let's do that first. So y-intercept just means that x equals 0, so you'd have y equals 0 plus 0 minus 35. So your y-intercept would be at negative 35, okay? And then to factor that, if you need to use AC factoring, that's fine, but to find your roots, I would probably say, well, since it's a 3, you know that it's going to be a 3x and an x. Those are going to be your the only way you can multiply to get to a 3x squared. So I'm going to say that that's going to be minus 7 goes there and the plus 5, right? Because that's positive 15 minus 7 gives me 8x minus 35. So to find my roots, I have to take each of those and set them equal to 0. So this thing has roots at 7/3 and negative 5. Okay, not the most beautiful root ever, but there it is. Okay, so determine the x-intercept, check, and the y-intercept, check. Okay, so to find the y-intercept, you plug in x equals 0. To find the x-intercept, aka the roots, you set the equation equal to 0 and factor however you need to do that. And then this question, the point -2, -10 falls on which of the following graphs, A, B, C, above. So the trick here is to know that if you're trying to figure out if a point lands on this graph, then you have to plug in and see if it makes the equation true. So if I was to plug in a -2 for x and a -10, and I wanted to know, like, if that was on there, it would make that equation true. So you would just need to plug in. And if I plugged in a -2 here, I don't think that's going to get me to a -10, because think about it, you're going to have 4 times 3 is 12, minus 16, minus 35. That's not going to be on B. So I know I could tell you the answer for this one's not B. You'll have to check A and C at a C. But make sure you know to see if a point falls on the graph, you plug in the x and y values to see. All right, more interesting though. Solve the polynomial inequality this greater than or equal to 0. Now I did this on purpose. See how we just spent all this time factoring that one? This is very similar. It's not exactly the same, but all I need to do is factor out an x to make it the same. Okay, so let's factor out an x. So if we pull out an x, we're left with 3x squared plus 8x minus 35 greater than or equal to 0. And again, I'm just going to steal those factors from up there. So I know that it's going to be 3x minus 7 and an x plus 5 for my factors. Okay? So if we're trying to figure out where this thing is greater than or equal to 0, okay, well, I know it's going to be equal to 0 at, so it's going to be equal to 0 at 0, 7/3, and -5. Okay? But what I would like you to do for these is kind of imagine a number line, and then you could do the test. Unless you want to graph this, okay, since you know where the zeros are, you could either option A, do a quick sketch and do your end behavior from there, or you could do the number line. So I'll actually do both. I'll do, so option A. Option A, the graph. So when I go to graph this, okay, I know there's a 0, so my zeros, or my roots, are at x equals 0, 7/3, and -5. So at 0, we'll go 1, 2, 3, 4, -5, and at 7/3, so I don't know if this is 1 and that's 2, right, 7/3 will be just over here somewhere, just a little bigger than 2. Now, option A really relies on you knowing the rules of your end behavior, or it's not going to work, okay? So you need to know that since this is an odd degree, it's falling on one side and rising on the other, and since it's positive, it's going to be falling on the left. So it's falling on the left, rising on the right. If you don't know your end behavior, then you cannot do option A successfully. Here, we know that we're going to cross at all of them. So you're just going to do something like that. And then you can very easily see where it's greater than or equal to 0. So it would be the parts where it's positive. So it would be this part and this part. So the answer from here, we said, would be -5 until you got to 0, union, and then from 7/3 to infinity. Okay, that would be how I did it using option A. All right, option B, if you don't know how to do your end behavior, that's really not going to work. So option B, either way you have to figure this part out. But option B is to kind of think of it more like a number line. Okay, so if you think of a number line, you know that -5 is over here, then 0, and then 7/3. You have to put them in order from least to greatest on the number line. Let me scooch over so you can see it. Okay, so once you have them in order, you have to go back to this line right here and imagine you're kind of plugging in a number and checking the positivity. So if I'm plugging in a number, let me switch, to the left of -5, so picture a number like -6. Well, if I plugged in a -6, this piece would be negative. If I plugged in a -6 there, this piece would be negative, and a -6 would make that negative. So a negative times a negative times a negative is overall a negative, okay? Then you have to plug in a piece in between -5 and 0, so like -1 or -2, okay? So if you plug in a -1, and again, you're going right here, this is the part you're plugging it into, that line. So if you plug in a -1 there, this piece is negative. If you plug in a -1 there, you get negative. But if you plug in a -1 there, it's a positive. So you're really taking a negative times a negative times a positive, which is an overall positive. Then you plug in a number between 1 and 7/3, like a positive 1. So if you plug in a positive 1 there, you get a positive. And then you get 6 minus 7, so that piece is negative. And then a positive 1 there, you get a positive. So you get a positive times a positive is overall going to be a negative. And then you plug in a number bigger than this. So I don't know, plug in like a 5. You get a positive. You're going to get a positive and a positive. So that overall gives you a positive. Now you say, all right, well, this part gave me a positive and this part gave me a positive. So that, again, you get the same answer from -5 to 0 is positive, and from positive 7/3 to infinity would be positive. So either way, I prefer this way, but again, that relies on you knowing the end behavior. I think that's a little shorter than option B, but you know, whichever way you can get it to work for you is fine. Okay, almost done, almost done. So given -3x to the 1/3, the power is 1/3. The constant of variation, right, is that 3, okay? And the graph is transformed by a, this is going to be a reflection over the x-axis, and it's also going to be vertically stretched, a vertical stretch, okay? All right, and then moving right along, let me scooch you up. We could see the end. All right, if a ball is dropped from a 32-foot platform and it's given by this, I think that might be a typo. I think that's supposed to be a different level of platform, because this would be a 64-foot platform. If the distance is measured, find the average rate of change over the interval. Okay, yeah, this should be a 64 if it's not already changed on your paper. Because if you plugged in 0, then you'd get 64, not 32. Okay, but anyways, so we're trying to find the average rate of change, okay? So the average rate of change, we need to figure out what is, it's going to be d of 3 minus d of 2 all over 3 minus 2. So the denominator there is easy. Now I need to figure out what is d of 3. So 9, so if you needed to do some side work, d of 3 is going to be -16 times 9 plus 64. And then we also need to figure out what is d of 2. Okay? So you have got -144 plus 64. That gives you 80. I'm sorry, -80. Okay? And then when you do the same thing with a 2, 2 squared is 4. Okay, 4. So you have -16 times 4. So that's -64 plus 64. Okay, so that should give you a 0. So when you go to plug those in, you have -80 minus 0. So you have -80 as your average rate of change. So that's -80 feet per second on that one. Okay, make sure you can tell the difference between question 35 and 36. 35 is an average rate of change problem. 36 is now saying that you're launching a ball with an initial velocity. If the height of the ball is modeled by this, what is the maximum height? Guys, that maximum height, that's asking you for the y value of the vertex. Okay, so very similar to those profit equations where it was asking for max profit and it wanted the y value of the vertex. That's what's going on here. So to find the y value of the vertex, first I need to find the x value. So to find the x value of the vertex, it's -b over 2a. Okay, So first we calculate the x value, then we're going to take that and plug it into the height equation. So this is not going to be the most beautiful fraction in the world. It's a negative 32. You can obviously reduce that. You get a positive. What if you divide both by 4? You get a 3/8. So then what you'd have to do to get the height is take 3/8 and plug it into the original height equation. So you'd say the height at 3/8, and then you'd plug that in. Now obviously this, if you are not going to have a calculator on your test, so I wouldn't give you one kind of this ridiculous. Okay, but just for the record, let's see, plug that in, and then I'd still have to do the +4 at the end. That's actually going to give you like 6.25, and again, I would just, know the process more for that one. I'm not going to make you do all that without your calculator, because that's just tedious. All right, and the last one, determine the x values that cause this polynomial to be 0, positive, or negative. So it's very similar to number 33. So you're going to kind of tackle this the same way you did 33, except for this one's a little bit easier because it's already factored. So it's going to be 0 when x equals -3, +5, or -2, right? Those are the roots. And then to figure out where it's going to be positive or negative, you can, again, you could either graph it. To graph it, you'd need to know that when you FOILed this out, you'd end up with an x cubed, right? A 1x cubed is your leading, a 1 is your leading coefficient, and x cubed for your degree, and then you could sketch it. Or you could just put those on a number line, and then check the positivity or negativity. So if I plug in a number to the left of 3, like a -4, this piece would be negative, that piece would be negative, that piece would be negative. So you'd have a negative times a negative times a negative, which gives you a negative. You plug in a number in between those two, so like -2.5. So if I plugged in a -2.5 there, I'd get a positive, and I'd get a negative. So a positive, negative, and a negative. So that means overall this would be a positive. And then I plug in a number between there. My favorite number to plug in is 0. So I'd get a positive, negative, positive, which is overall a negative. And a number bigger than 5. Positive, positive, positive. So positive, positive, positive. So that's overall positive. So that means this thing would be positive between -3 to -2 union 5 to infinity. And then it would be negative from -infinity until -3 union, and then it was negative again between -2 and 5. Okay? All right, make sure you study this stuff, and you should be good for the test. Have a great day.